All right, welcome to The Explainer. Today we're jumping into a climate paradox, one that sounds like it just shouldn't make sense, but it's happening all over the globe.
I mean, think about it. How can one thing, a warmer planet, cause two totally opposite problems? We're talking more intense flooding and more severe droughts. How is that possible? Well, stick with me. We're going to break this all down piece by piece.
Okay, so trying to wrap your head around the Earth's entire atmosphere, that's huge, right? So we're going to do what scientists often do. We're going to start small, really small. We're basically going to shrink the Earth down into a simple lab experiment.
Yep, you heard that right. A bottle. You know, sometimes the only way to figure out a giant complicated system is to build a little version of it. A model lets us tweak things, control the variables, and really see what's causing what. Something that's pretty much impossible to do with the actual planet.
So check out this setup. It's beautifully simple. You've got a bottle over some wet soil. That's kind of like our humid, flood-prone region. And then you've got another bottle over dry soil, which represents a drier, drought-prone area. The bottle just traps the air, and a little sensor inside keeps track of the temperature and humidity. It's literally our Earth in a bottle.
Okay, so what happened? Let's look at the results. This chart shows what happened to the humidity in just 8 minutes. And what's interesting is the humidity went up a little bit in all the bottles, even the ones without extra heat. But look, the real story here is the heat. When you add heat, boom, the humidity skyrockets in both the wet and the dry setups. This shows us something super important. More heat basically puts the whole evaporation process into overdrive.
So right there, that's our first big clue. It's just basic physics, really. You add heat, water turns into vapor faster. But here's the other part of that. Warmer air can actually hold more of that water vapor. So think about that on a global scale. A warmer world isn't just pulling more water up from the ground and oceans. It's also making the atmosphere itself kind of thirstier, able to hold all that extra moisture.
Okay, but wait a minute. If there's more evaporation happening everywhere, shouldn't that just mean it's rainier everywhere? It seems logical, right? Well, our little bottle experiment was great, but it left out one huge real-world detail. And that one detail, it changes absolutely everything.
And here it is, the big difference. In our lab, the bottle was a closed system. All that water vapor was trapped inside. But Earth, it's a gigantic open system. There's no bottle capping it off. Instead, you've got wind. And wind is constantly pushing that air and all the water vapor in it all around the globe. And that, my friends, is the game changer.
So to see what really happens with all this extra water vapor, we have to zoom out from our little lab experiment and look at the big picture, the whole planet. And to do that, we're going to look at some amazing data from scientists who track this stuff 24/7.
Yeah, scientists at places like NASA and NOAA use satellites and all kinds of tech to create these incredible maps of stuff we can't normally see. We're about to look at what they have found, a visualization that shows how water vapor actually travels through the atmosphere. This is where our simple bottle experiment crashes right into complex, messy reality.
So what are we looking at? Well, first thing you notice is that water vapor isn't spread out evenly. Not at all. It's all clumpy. You see these huge concentrations, especially over warm oceans like the Gulf of Mexico. Second, this stuff is moving. The winds create these clear pathways, almost like invisible rivers flowing through the sky. And you can also see that some places, like the West Coast, kind of get missed by these huge moisture streams. Things like cooler ocean water or massive mountain ranges can actually block or divert this flow of water vapor.
What this really means is that our atmosphere is like a giant delivery service. It picks up moisture from one area and just drops it off somewhere else. So you've got some regions that are right in the middle of these moisture highways and they get soaked. But then you have other regions that are left high and dry. Any moisture they have just gets picked up by the wind and carried away.
All right, so now we've got all the pieces, right? From our bottle, we learned that more heat means more evaporation. And from the NASA data, we learned that wind moves all that moisture around unevenly. Let's put these two ideas together and finally solve this paradox.
I love this because it shows how our understanding has grown. On the left, you've got our simple model from the start. Heat goes up, evaporation goes up. Simple enough. But now look to the right. It's almost the same picture, but with one critical addition. Wind. That single factor changes everything. It's the wind that takes all that extra moisture and decides where it's going to go. It determines who gets the rain and who doesn't. And you know those invisible rivers we were talking about? They actually have a name. Scientists call them atmospheric rivers. They're basically these long, skinny corridors in the sky, just jam-packed with water vapor. And when one of them hits land, it can dump an unbelievable amount of rain or snow. They are literally the delivery system for some of the biggest floods. And so, here it is, the solution to the whole paradox. A warmer world pumps way more water vapor into the air. That's the fuel. But the wind acts like a delivery truck, and it doesn't deliver evenly. The places that are in the path of these atmospheric rivers get hammered with intense rain, causing floods. At the same time, the places that get bypassed, well, they still have all that extra heat, sucking moisture out of the ground, but the wind just carries that moisture away, leaving them even drier than before. The dry get drier, and the wet get wetter.
So you see, the story of floods and droughts isn't really about how much water there is in total. It's about where that water is going. It's a massive, planetary system of pickup and delivery. And as the world keeps getting warmer and there's more energy in that system, the one really big question we have to ask is, where are those invisible rivers going to go next?